This question is called Dart Game, and it says Jason throws two darts at a dartboard aiming for the center. The second dart lands farther from the center than the first. If Jason throws a third dart aiming for the center, what is the probability that the third throw is farther from the center than the first? Assume Jason's skillfulness is constant. So I'm gonna start like dragging the questions along so you can see. Like I'm gonna like pull it down more often. But yeah, so we were saying Jason is throwing darts at a dartboard. So let's first draw out this dartboard and see what's happening. He's throwing three darts. Into the center. We can say firstly, how many ways can you throw three darts at a dartboard? How many ways can they be ordered? So the number of ways you can order anything actually is the number of things you're throwing factorial. That's like the number of permutations you can have of this of the darts. So there's 6 ways for these darts to be ordered. 6 ways. 3 factorial. For example, it can be A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. But we said that the first dart, dart A, is closer to the center than dart B. So the second dart is farther from the center than dart in the first, aka our dart A. So we're saying we threw dart A, went somewhere here, and then we threw dart B and it was like here. So it's farther from the center than the dart A. So if we look at our possible orderings, which ones can we not include now? It's any ordering we see that B is before A. Right? If we say this is the center, and this is how far each thing is from the center, and A is the closest, B is the second closest, and C is the farthest in this case, right? And we're ranking how close they are to the center. So which orderings can we see where B is farther from the center, or is closer to the center than dart A? So we can see here it's BAC, BCA, and CBA are orderings where B is closer to the center than A, which is not allowed because the question said it's not allowed. So we can get rid of these, or we can rewrite the ones we are working with that are allowed as ABC, ACB, and CBA. So now we can see that dart C, we're saying what is the probability that the third throw is farther from the center than the first? That means that A has to be before C, and that's all we care about. Well, here A is before C, so that's good. Here as well, A is before C, that's fine too. We're saying, in this case, we're saying C is here. It's after B, but after C as well. That's what matters. And here, it's before B, but after C. But all we care about is A being after A. But here, it's closer to the center than A, which is not allowed. So this one is the case we're going to say that's our failing case. So there's 3 outcomes we were considering, and 2 of them work. So there's 2 orderings of 3 that answer our question, that have an answer to this question that is what it's asking for. It's saying the chance that the third throw is farther from the center than the first, and then 2 of the 3 scenarios, the third throw is farther from the center than the first. So it's the answer here is 2/3. But this is very brute force, as in we're listing out possible orderings, seeing which ones are allowed, which ones aren't, and that works when we only have 3 darts, right, or 2 darts thrown initially. But what if we have 5 darts, 8 darts, 10 darts, 12 darts? This question falls apart, or this method falls apart pretty fast when you have more than 2 or 3 darts being thrown, because factorial is the fastest growing thing in math. Like besides like 2 to the n, n to the n to the n maybe, or like 2 to the n factorial. But factorial is one of the fastest growth rates in math. So and we have factorial to count our number of orderings. So how can we do this without counting out explicit orderings? To do so, we have to reframe the question. Now, how do we reframe the question in this case? Instead of, what you can see is the case that worked is the case where A remains the closest dart to the center after the n+1th throw. So in the first, so let's say n2, in this case 2 was n and 3 was the n+1th throw. The cases that worked were the ones where, so we already conditioned the question such that in the first n throws, dart A was the closest one to the center. Then the third throw came around, the n+1 throw, and the cases that worked were the ones where after the n+1 throw, A was still the one that was closest to the center. So we can reframe the question as having events, right? Event 1 is where dart A is closest after n throws, and event n+1 is the case where, dart A is the case where dart A is still the closest after n+1 throws. So the chance that, so we're trying to find is this event E n+1 is our goal scenario. We're trying to find the probability of. So E of n+1 equals 1 minus the probability of event n+1 is 1 minus the probability that we call it event C is where dart C is closest after n+1 throws. And these events are independent, event 1 and event C, because if dart A is thrown, and then we have n throws total, and A is the closest dart in the n throws, C can also, both can be true. A can be the closest dart in the first n throws, and C can be the closest dart in the n+1 throw. Both can be true because we're saying, oh, okay, I'm going to have the best score in the first 3, and then the 4th throw comes along, and it's better than me. But the first 3 part was still true. I still had the best score in the first 3, but the one after just changed its own event. My case was still true. I was still the best throw in the first 3. The 4th throw might have dethroned me, but the first 3 I was still 1. What's happening here as well? In the first n throws, A is the closest, and on the n+1 throw, C may or may not be the best. But both can be true, therefore they're independent. But that's not why they're independent, but you can see why they're independent. So now we're saying the probability of E n+1 is 1 minus the probability of event C. We're saying event C is where C is the closest dart after n+1 throws, and we're saying event n+1 is the case where A remains the closest throw after the n+1 throw. So they're complements, right? So yeah. Now, what's the probability of event C? Well, the chance that dart C is the closest dart after n+1 throws, we have to look back at this part of the question. Actually, I'm going to bring this down so you can see it better, just so it's there. So it says, assume Jason's skillfulness is constant. That means each throw is independent, and thus any given throw can be our new best one. So it's like saying, I'm going to throw the dart 5 times. I'm going to throw it the same way every single time, right? The chance that any given dart is the closest one is 1 out of 5. So the chance that the n+1 throw is the closest one after or dart C is the closest one after n+1 throws, aka the n+1 throw is the best, is 1 out of n+1. So again, like for the 5 throw example, the chance that the best out of 5 throws, the one's the best. Like the 4th throw is the best is 1 out of 5. The chance that any given dart is the best of 5 throws is 1 out of the number of throws we have. So event C has probability of 1 over n plus 1, and we're looking for this event E n plus 1, and so we just compute this out. 1 minus 1 over n plus 1 equals n plus 1 over n plus 1 minus 1 over n plus 1, which equals n over n plus 1. That's the general solution. And so if you look at this example we had earlier, where initially we had 2 throws, like 2 darts, and in our case, n was equal to 2. You plug it into what we had generally, you see you get 2 out of 2 plus 1, which equals 2/3. So we got the same solution, but now we unlocked an arsenal that allows us to solve this question for more than 3 throws, or more than 2 initial throws.